Hi, I'm Paul Germain, and welcome to another session of Smart Boating. As you know, if you watched the show before, we cover a wide variety of topics from man overboard to marine insurance. And typically the idea is to give you some information that will help you make smarter decisions on the water and have more fun. Every now and then we take a little side trip down into an area which I think you'll find very interesting, and that's the case today, where we're going to look at outboard racing engines. And joining us today is an expert in that area. His name is Billy Allen. Welcome, Billy.
Thanks for having me, Paul. Glad to be back.
Good to see you. Hey, we got a cool show here today because I think what we're going to do is explore the world of outboard racing engines, which have a strong parallel to what people would find on their 14-foot Starcraft, for example. But before we get into that, can you share a little bit about your boating background and specifically in the area of racing?
I've been racing in the American Powerboat Association for over 35 years. I also race internationally in the UIM. And I've been fortunate enough to be around a lot of good mechanics as I came up through my racing career. I wasn't a trained mechanic, but I've been around a lot of smart guys, and you learn a lot by standing around and listening. So, and because of economics, like a lot of boat racers, motorcycle racers, car racers, you learn to do your own mechanics along the way because you just can't afford to have other people do it all the time. So it saves time, it saves money, and it's fun to learn.
All right, so you've been doing this for a while, huh?
Yeah, I've been racing for quite a long time, and like I said, you know, you learn fooling around with engines. You learn a little bit from all the different guys you know, and hopefully you know enough at the end to take a motor apart, rebuild it, fix what's wrong with it, and put it back together. Good.
Well, you get just the right experience for the show today.
Yep.
So why don't we get into it?
Fine with me.
Well, Billy, you know, it's going to be an interesting show on the outboards, and you know, we can't cover it all because we don't have enough time, but we can hit the high points, I think. And we've got a couple engines here. Can you share with us what's the difference between this engine and this engine?
Yeah, these are two very unique racing engines. They're very similar and they're very different. Mm-hmm. This is a 15-horse Johnson that raced in our A class for many years, and it's a basic two-cylinder, same as this, one carburetor, same as this. But what this is a converted fishing engine, where this engine is made strictly for racing.
Okay.
So if you pull that top, Paul, I'll show you that. Not only does it have a cover, which this engine doesn't have, it has a bottom pan, which this engine doesn't have. It has a recoil. This one starts by wrapping a rope around the flywheel.
Okay.
So by eliminating all those things, the pan, the cover, the recoil, it does a couple things. It lightens up the engine. Mm-hmm. It makes it easier to get at the components to take it apart quicker. Mm-hmm. And it also just makes it easier of operation. Yeah. Because you don't have things that'll break like this recoil, and you'll miss your race or something like that.
You don't have time for that in racing.
Yep.
Now, how many horsepower did you say this one?
This is a 15.
Yep.
It races in the A class, and this is a 30 horsepower races in the C class.
Are they different sizes?
Yeah, the pistons and the cubic inches are. It's almost half. This is a 15 and this is a 30.
Oh,
so,
really?
So
okay.
it's almost double the pop.
Not only in the approach, but also in the power generation.
Right.
And this is a much, like you say, much simpler engine to work on, which is.
It is.
Racing, you don't have time to be fooling around with
You'll
stuff,
see
right?
this has a choke and just the same thing your fishing motor would have.
Yeah.
So this motor's made to put together at the factory one time, run it for 20 years, and you're done with it. This one is made to rebuild all the time, so everything's much more accessible, and it'll as you'll see in the show, it'll come apart really
Easier
quick.
To get on. Now, can we give people a quick overview of how an engine actually works, starting with the carburetor up here?
Sure. These engines are actually very much the same. One carburetor, two cylinders. So what happens is this engine has a top mount tank that gravity feeds into the carburetor. Right. So this one has a fuel pump. So this engine, the tank would go in the boat.
Right.
And then the fuel pump would suck the fuel up. This has a gravity feed. But after that, they're basically very, very similar. Yeah. They have one carburetor, which is inducing air, just like a vacuum cleaner, as the engine starts. When you turn the crank with the rope, it'll cause a suction here. It'll also cause gas to fuel to come in with the air.
Yeah.
So as that fuel and air mixture goes into the crank, it converts around and into the port windows.
Moves around it,
It gets compressed by the piston. As the piston comes up to top dead center right here, it'll compress that fuel air mixture.
Yep.
And then
And
your
it blows
spark,
up, right?
your spark will come down the spark plug right at that exact moment when that piston is coming to top dead center.
Yep.
That exact moment is called your timing.
Yep.
So when that spark goes, it causes an explosion in the combustion chamber, forcing the piston the other way, and then the other piston comes down.
Right. Which
And that
rotates this whole assembly here. And
rotates
then
the whole assembly.
connect that to the drive shaft.
Yep,
into the
and it goes down
propeller.
into the gearbox, and it makes the prop turn, and off you go.
Right. So again, the fundamentals of this racing engine are the fundamentals of this fishing engine.
And almost every engine that you see that's a regular old small two-cycle outboard.
Isn't that something? Mm-hmm. Well, Billy, you've got a racing engine right here, right now, and we're going to take that apart to help people understand all the individual components that make it up. I guess our first step would be to take it off the drivetrain, right?
Yep, the first thing we're going to do is take the power head off the midsection so we can put it on the table and disassemble and take a look at some of the internal parts.
Okay.
So we'll get this off.
All right. It comes right off.
And
Let's take
we'll
this.
take our spark plug wires off. We'll take our spark plugs out. And then with just one nut here, the cylinder head will come off.
Okay.
So let me just get this out quick. We can look at a spark plug here. Okay, and then this one. We'll get our cylinder head off clean.
Okay.
So there's your cylinder head.
We'll be talking more about that.
Yep, there's your cylinder gasket, head gasket. And then we've got just one. This takes 6 nuts to hold this on, but we've only got one, so we can take it apart quick and show you.
All right. But even if you had 6, they'd come off pretty fast,
still
right?
would be a very easy operation.
Okay.
So
Take that
we can
off.
take this jug right off now.
Okay.
Oh, let me get the gasket
Yep.
off here. And there is your cylinders.
That's the cylinders. We're going to be talking a lot more about these later. But let's focus in on, this is really the core part of the motor here. And basically running down here is the crankshaft, right?
Crankshaft runs straight down here. You can see it in here. You can see it rotating.
Okay, right at
Right
the
in
base
here.
of the
Yep.
connecting rod here.
It's a series of discs on a straight lash down the middle.
Uh-huh.
So when you pull the rope, of course, this turns, and you can see how your pistons will go up and down on the cylinder block.
Right, so this is the cylinder here.
Yep,
and
cylinder
they're
would be
moving in and
there.
out,
Yep.
And they're really being driven back and forth by those explosions that
By
are
the
happening
explosion down in
combustion
the
chamber,
cylinder
right?
head. Yep.
So the spark plug's at this end, it's making an explosion here, which is driving this down, right? Driving it down like that.
Each explosion would cause the pistons to move, and this one will drive that one down, and then it will just create a circle the whole time.
Right.
So you'll just be going back and forth like that.
Yep.
And your spark plug would be right about here. So when that sparks, that causes the explosion, pushes the piston up.
Excellent. So the crankshaft, this center shaft, is really important.
It's really important. It's held on by 3 main bearings, one at the top, one at the center, one at the bottom, and it looks a lot like this bearing here, a very stout bearing that holds around the crank and keeps everything straight, because
Yeah.
the secret to good performance is a nice straight bore, correct clearances, and a nice straight crankshaft.
You don't want it vibrating around.
You don't want anything out of balance or out of sync.
No,
Yep.
that would be bad news. So this is the bearing for the crankshaft.
Yep.
And then I've got a smaller bearing here, and this is for
That would
the
be
connecting
for the connecting rod. So this connecting rod would, as you can see it here, it connects the crankshaft to the piston, just like that. So there's a bearing in here,
Yep.
and there's a bearing around here. So you
Yes.
get rotation here, and you'll get rotation in here. So everything's held together by very stout bearings, keeps the crank nice and straight,
Okay.
and keeps the pistons going back and forth at a nice straight angle. So
Couple
straight
quick
round,
questions.
straight round bore is the key.
Yeah. Now, in this type of racing that you do with this motor, do they allow you to modify things like connecting rods or crankshafts?
No,
that sort of thing,
this
or
is a
does it have to be
stock class engine. They also have a modified division for this engine too, where you can get into that
Okay.
kind of thing.
Okay.
But we're working with just a basic plain stock engine today.
All right. So we got crankshaft, we got the connecting rods, and then you've got the pistons, which we can see there. And here's another example of it here. It's got, what, it's like a It's like a can almost with
Yep.
with 2 rings on it, right? Can you help us understand how that works?
Yep, these rings supply the compression. They expand and
Yeah, they're
run
springy.
against the cylinder wall, so they are compressing all the gas and oil down into that area where it's going to have the explosion.
Otherwise, it would seep by.
It would
this
just
piston,
seep
right?
by. Yeah, this piston's pretty cruddy. This was in a motor that got pretty hot. So as you
Oh,
can see,
okay.
you've got a little blow by here,
Yeah.
which is bad. You want the piston to be nice and shiny down past the rings. That's when
Okay.
you know it's worn out. So these pistons come out of another motor, but we just wanted to show them today to see what a used, worn-out piston
Right. Here's
will
the
look
new one,
like.
huh?
And of course, you want to replace it with a nice new piston. Now, if you have new pistons and you're going to have the block board, you want to send your pistons with the block so your machinist can get the perfect amount of piston clearance in your block.
All right. Now, people talk about revolutions per minute, right? And my engine's turning 6,000 revolutions a minute. Looking at these pieces, that means this crankshaft is going at 6,000 revolutions per minute?
7,000.
7,000.
Yeah, about 7,200 is what we're looking for with this engine in the stock configuration.
That's
so that,
really moving a lot of machinery around
yeah,
pretty darn quick.
It really
right?
is. It really is. It's a very stout engine. It
Stout
stays
engine.
together pretty good.
Does it?
Yeah.
Well, Billy, we've been talking about the internals, crank, connecting rods, pistons. We put the cylinder head back on here just so people can get context of how they work together. We've got the pistons entering into the cylinder head here. Let's focus in on the cylinder head for a moment. Can you take that off and we'll bring it over here and talk about it?
Okay. Yeah, we already had this off once. We just kind of put it back here so you can see. So there is your cylinder head right there. Or your cylinders, rather.
Okay. Do you want to take this exhaust?
Yeah, we have one little nut holding this exhaust port on, this exhaust cover. So I think we get this off so people can see better inside the working area of the combustion chamber here. So
Yeah.
there you go.
So let's talk about the cylinders first, and then we'll talk about some of the way they get to the full. So this is, again, is where the pistons rotate in and out, right? And these are a certain diameter or bore, right?
Yes, yes. You want your cylinder to have the exact clearance for your piston, so you get the right clearance around the piston. Usually it's about 3.5 thousandths. And then you want your ring gap to be perfect, and that's what gives you a lot of pop inside your cylinder.
Nice tight fit.
Now, the other thing is, these cylinders, after running a long time, will get worn in and they'll almost look like a mirror.
Yeah.
So what you want to do then is you want to put a hone through it and
Yeah.
get some scratches back in that cylinder, because oil will migrate better back and
that's a
forth
good
through
point.
those scratches instead of having it shiny like a mirror.
Right.
So what we usually do is we'll take the port cover off and just look in there at the pistons, and we can see the other side of the cylinder and just do a little visual inspection.
Yeah.
So the other thing you have here is you have your fuel intake
Yep, the
on
ports.
this side on the port window.
We have a flashlight.
Yep, we can see them right in there. So
Okay.
the gas is coming in one side,
Yes.
and then it's exploding here, and the exhaust is going out the other side,
Other side.
and then down into the exhaust tube. So this is
Okay.
really the business end of what's going on here. Is
Right.
the explosion's happening, the fuel comes in, the explosion happens, and it turns from fuel into exhaust into gas then,
Yes.
and then the gas goes out as exhaust.
And it comes out this area over here.
Yep. So a nice straight round bore, a good scratchy surface, and the right piston clearance is really, with a stock motor, there's not a lot of tricks. It's just about doing the simple things right.
Right. So I can't, these ports that are allowing the hot gases to come in and out, I can't change those, right, on this particular
Not
motor.
in a stock class, no.
But again, similar to any other outboard, two-stroke outboard, it's working the exact same way. It's letting the pistons that are going up and down, they're letting gases in, they explode the gas, and the gas goes out through the exhaust.
Exactly. The difference being this: in a racing engine, if you take a bore gauge
Yep.
and you put it in here, you can actually see if that bore is perfectly round.
Yes.
And if the bore isn't perfectly round, this is something you'd never notice on your fishing engine. It would go forever.
Yeah.
But if you're a couple thousandths out, it's not going to be a great racing engine. So these
Okay.
are the little things you really have to look for in a racing engine.
All right. So let's say it's more egg-shaped than round. You can bore it out with a tool like this, right?
Yes, you can take a hone, a cylinder hone, which has different grits, just like sandpaper.
Yep, yep.
And that will go in and expand. You put it in a drill,
Yep.
and then you can go back and forth with that hone a few times and actually straighten that bore a little bit.
You can.
Some guys are really good with a cylinder hone, and they can get your bore back straight.
All right.
After you're done with this hone, what a lot of guys do is they'll take this hone and just give it a quick pass through
Okay.
to get those scratches back on the cylinder that you're looking for. So you'll have better grip with your rings and better oil migration of your gas and oil through the cylinder block.
Interesting. So this is another key element to having the motor run correctly.
Yeah, between the crank being nice and straight,
Yeah.
your bore being nice and straight, and your clearances being correct, that's really where the rubber hits the road in racing engines.
Okay. Well, Billy, we've been talking about how the roundness of the cylinders is so critical to a racing outboard engine. And we've got the setup here where we can do some honing, right?
Yep, so what we did, first thing we did was, again, we checked the bore with our bore gauge, and we found that it wasn't quite 100% perfectly straight. It was about almost 2 thousandths off in the middle.
Okay.
So we took our cylinder hone and we went back and forth a few times and straightened it out as best we could. We rechecked it. So now what we're going to do is just dress the finish, because now the finish is very shiny at first. So what we're going to do here is we use our regular gas and 2-cycle oil.
Okay.
We give that hone a little dip in there.
All right.
And then so we don't splay it all over you, we're going to put this down in here a little.
Good.
And then we just go back and forth, nice and easy, and put those scratches back on that cylinder wall. That's about all you're going to need right there.
Oh, really?
Yeah, just a little bit,
Yeah.
yep.
Mhm.
If it's really bad or it has a score, you're going to have to work a lot harder.
Yes.
But
yes. These
this
are pretty
one,
decent shape,
basically, you just want to give it a little cleanup, and that's really all you want to do.
yeah. Oh, okay.
And it's as simple as that. Now you can go ahead and look in there, and you can see how we have a nice scratchy bore now. We're going to have better oil migration.
Yep.
And better ring grab, as I call it, on the from the ring to the surface of the cylinder, which will give you more compression, make sure all that gas and oil is getting pushed right down to that end and nothing's blowing by. So that is a nice regular hone job, and we're ready to go back together now.
Perfect. Well, Billy, we've put the engine back together here, just tacked it together so people could get context again of our crankshaft, our cylinders. Now we're going to talk about the head, right?
Yep, we're going to take the cylinder head off. It's already loose, so we're going
How
to.
many bolts does it normally have?
This is 8
6
bolts.
or 8?
8 bolts to keep it on.
Yeah.
And this is the business end. This is where your combustion happens right here. So that is where the piston comes up, goes right into that spot, makes the pop, makes the explosion. So that's your little cup here. That's the spot
Combustion
where the
chamber, really,
yeah,
right?
the explosion is actually happening.
Right,
So
right.
there is.
Are there different sizes of these? I
Yep.
think we've got another size over here.
It's actually not a different size head. It's just a different size spark plug hole.
It is.
So one is an 18 millimeter spark plug. This is the way the heads come. They come two different ways, with the 14 or the 18.
Okay.
So there's really not a big difference in performance.
There isn't.
But the big difference is, if you have the 14 millimeter head with the smaller spark plug, you have a wider variety of heat range spark plugs you can choose from.
Oh, okay.
With the big 18 millimeter spark plug, there's only a couple of heat ranges.
Oh, really?
So between your timing, your tuning of your carburetor, and your spark plug heat range, that really is the heart of tuning a 2-cycle engine.
okay.
So
All right.
heat range of your spark plug, depending on the time of the year, the humidity, it can be very, very important.
All right.
So we like the 14 millimeter heads just because you get a bigger range of
Oh, you do?
spark
Okay.
plug heat
All right.
range
All right.
to choose from.
All right. And this actually mates with the cylinder head through a gasket, which is pretty important, right? Mm-hmm.
Yep.
That's kind of a relief valve, isn't it?
Yes, the head gasket, when because it is a racing motor, we
Yeah.
tip them over once in a while.
Once in a
so
while.
when they tip over, sometimes they can ingest water,
Yes.
and then that water gets stuffed into the combustion chamber, and the piston comes up, and there's nowhere
Can't
for that
compress.
water to go. So
Things break.
what you will do is you'll blow a head gasket. It's almost like a fuse.
That's what it's designed for, really, right?
It is. Instead of bending a rod or breaking something coming through the crank because that water has nowhere to go, you'll blow your head gasket, and that's a nice easy fix.
Right. So there's a lot of thinking that goes into it, from the
Yeah.
spark plugs to the size of the head to the gaskets, and a lot of stuff going on back here.
Yep, and especially when you're in competition, if you take a spill and tip over, the first thing you want to do is take that head off and check that head gasket because the motor won't start again, even if you do everything else right, if that head gasket is blown. So it's actually a very good system for racing.
Yes,
And,
yes. Well, Billy, as you look at the engine again from another angle, it needs, of course, as a basic requirement, a fuel-air mixture, and the responsibility for that falls to the carburetor and the reed valves, right?
Mm-hmm. Yep, the reeds and the carburetor consist of your whole, pretty much your whole intake system. Mm-hmm. So we're going to take a look at the reeds right now. We'll take the carburetor off first.
Okay.
And I'll hand that to you.
Yep.
And we'll talk about that in a minute.
Yep.
But in the meantime, we're going to take the reed plate.
Mm-hmm. A lot of people don't know what reed valves are.
Yeah, they just limit, they control the amount of fuel going in. So there's a good picture right there of the reeds.
Yeah, they fit right behind the carburetor, between the carburetor and the crankshaft.
Yep, and this will come off. Get a gasket there. And you've got all your reeds. Yeah, give me a hand there. Gasket hooking up there.
Okay.
And there you go.
So we've got this is where the carburetor is over here. So the engine is actually sucking in. It wants to suck in air fuel. Those pistons going up and down, they create a suction, right?
Through all these little holes. Yep.
Yes.
Yep. So that's what will be sucking them in. Now, if you turn that around, you can see that each reed has a stop because there's a spec on how high that stop can be to allow how much fuel goes in that hole by that reed.
Right. So these little reed valves are like spring metal, right?
Little flappers. Yep.
Yes.
Yeah, and that's what they do. So if these stops are too high, there is a spec on that, so you can get disqualified at tech if the stops are too high. So it's important to set these reed stops at the maximum they can be without being over. And there's a lot of them, so it'll take a while to get that perfect.
Yeah.
But that is basically between your carburetor and your reeds. That is basically your intake system, how the motor is ingesting fuel and oil.
It's the path.
Fuel and air.
So these are key, and a lot of people may not know about these, but these in two-stroke outboards, they're in there too.
Yep, and they're very important.
Yep. Now here's the carburetor here. Let's get this positioned
Yep,
correctly.
this is a manually adjusted carburetor. It does not have a set jet. So what you do is you turn this like a faucet, depending on how much fuel or air or how much fuel you want in there. So what you want to do is
the air's coming in through here.
Is coming in through here, and then your fuel is coming in that little tube in there.
So like a little thing that sticks up into the air passage.
And this will adjust how much fuel is going in. So if you have a real good day, what I call maybe a good running day or a good football day where it's crisp and clear and there's good air, you'd want to open that up a little and let a little more gas in.
Make it a little richer.
Yep.
It's like choking.
Exactly. If it's a stingy day, a hot, humid, sticky, less oxygen in the air, so you'd want to go with a little less gas to keep that flow the same.
Keep it lean.
So that's why you have to adjust that on race day. Usually it's only a little bit, but you have to be sniffing the air and seeing what it's like. So
Right. So this is a really important piece. Now you've got one apart there.
I've got one apart here so we can see now. The fuel coming in here will activate this float to actually float. It will literally float up. So your float level is important, how much fuel that bowl is holding.
I see.
So then that'll go through here, through your jet. Yeah. And this little faucet, you can see that little needle on the top is controlling how much fuel is going into the...
So it comes into the bowl, and then it goes in, and that meters it out into the air passage.
Yep, and if you have that too open, you'll get too much fuel. If you have it too far closed, you won't get enough fuel. So the trick is to find that sweet spot right where you want it.
Billy, we've been talking about the basic operation of the engines and the pieces they need to run effectively. They need carburation, they need induction, they need internal mechanicals, and of course the other thing they always need is gas and a spark, right? So the spark is actually generated here. Part of it is generated by the flywheel, right? How does it work?
So you need three things. You need compression, basically you need spark is the only thing we're missing here. We've already gone over the fuel and air mixture, the compression. So now we're working on how does this explosion actually happen in the combustion chamber. So a lot of the older flywheels, the engine we looked at before, the OMC, the magnet there would be a magnet placed right on the flywheel.
Yes.
Now the flywheel, this is only the rope plate to start this engine, so the magnet is actually located down here in the part that reciprocates.
Yes, okay.
So what you have is a magnet sitting on that flywheel, and then you have a trigger which is stationary.
Yes.
So every time that magnet passes that stationary trigger, it makes a spark.
Yes.
So that spark then travels down the spark plug wire and into the spark plug and forces that spark to happen right as that gas and oil, air and gas mixture is going toward top dead center.
Everyone's sealed up. And
Yep, everything's sealed
lights
up.
it off.
So the important part is this moves back and forth,
Yes.
and that adjusts when that trigger is, when the magnet is going by the trigger, and
timing.
that is your timing.
Timing, right.
So when that spark happens is crucial to the operation of the engine. It has to happen. That spark has to happen at the exact moment you want it to.
Right.
And that's why you will adjust the trigger to pass that magnet, for the magnet to pass that trigger by moving the trigger.
Okay.
That gives you your spark, and that's the last part of the equation, and that gives you your pop inside your cylinder. So what the important part is to have that spark happening at the exact time that you want it to happen.
Yes.
So that is your timing on any engine.
Okay. Well, Billy, the final process in an engine like this working is to get rid of the exhaust. Can you show us a little bit about that?
Okay, well, we've covered everything pretty much up until the combustion chamber. The fuel comes in, gets exploded, turns into exhaust. Where does the exhaust go?
Yes.
The exhaust goes, this is the exhaust cover.
Okay.
So that goes like that. The exhaust will come out the port windows, be deflected in here, just like a little ramp.
Yes.
And then get channeled right down this hole, which then goes into the exhaust pipe of the lower unit of the midsection and then out the snout down here. So having this gasket tight, having no leaks, having this nice and tight, having your whole exhaust system nice and tight and not leaking is, again, very important in a racing motor. So we keep an eye on these things too. So that's where the exhaust goes. It just goes out of the holes, deflected down through that hole, down this hole, and out the snout right here.
Right. And this is a real science, really. Some classes, I imagine, they allow you to modify this component, and others they don't, right?
In a modified class, you would see this exact motor with a big pipe sticking way out the back, about 3-4 feet, that would add a lot of power to this motor.
You can get a lot of power out of this particular aspect.
Messing with the exhaust, you can put an exhaust, a tune pipe on there and pick up 5 miles an hour at least.
Wow.
Yep.
Yeah. Okay, but in the class that this motor runs in, got to keep it stock.
You've got to use the stock cover. Yep.
Okay. All right. Well, Billy, we're at the final stage here. Looks like you got the motor on the boat.
Yep, we got this engine all rebuilt. We've got it honed, new rings, all put back together. So we're gonna, we put it on the boat. We've got it all primed up. We've got a little bit of gas in the tank, so we're gonna give it a rip and see if she goes.
All right.
So we'll start just by coiling this around. It's a nice little easy rope start. We'll give it a little gas on the throttle and give it a good hard pull and see how she goes.
Billy, it's hard to believe, but it's time to wrap up the show today. And we've covered a lot of material. We've covered the internals. We started with the crankshaft and the pistons and the cylinders, and we went to the heads and the carburetor, and right down to the connecting rod level. So I'm hoping people got a lot of useful insights, not only how a racing outboard works, but how their regular 2-cycle outboard works. Is there anything you'd like to add before we wrap up the show today?
Well, it was just, it's always fun to be on your show. Last time we really get into the boats and the hulls. It was nice to get really into the engine this time and figure out, you know, see what's making it work in there, and maybe some people at home learned a few things. And just wanted to say, if anybody's interested in seeing an outboard race, they can always go to southshoreoutboard.com. That's our local club website, South Shore Outboard Association, that we race under, or stockoutboard.com is the national website if you're not from the Boston or New England area, and love to see you at the races.
Yeah, excellent. Thank you.
Thank you, Paul.
And thank you, Smart Boating viewers, for joining us today. If you have comments or questions, come to our website, www.smartboatingus.com. Thank you.